Okay, so this is the panel discussion. This is basically why might you want to choose a parachain or a smart contract, potentially an independent blockchain, but let's not worry about that too much. We really want to focus more upon the parachains, as we've just described, both myself and Adrian, or why might we want to keep building with smart contracts? What are the trade-offs? And we have, I guess, shall we say, experts on the stage, and myself, and then all of you great people. So if you have questions, if you raise your hand, I shall try to run out and give you the microphone and let you join in. We do want some interaction, but I'm going to try and kick off with these guys. So if I just start with a very quick introduction of each of you, if you want to just say something very brief about yourself, introduce who you are, what you're working on, and then we'll get on with the discussion.
I'm Adrian. I work on validators and developer adoption.
I'm Andrew. I currently work at Parity Technologies. We're developing the substrate framework that was well advertised here. And I've worked mainly on Parity Ethereum, but I've done bits and pieces on substrate.
Hi, I'm Alistair. I'm a researcher at Web3, the Web3 Foundation. I'm involved in the design of Polkadot.
Yeah, mainly around consensus and finality.
Other things.
But yeah, so Alistair does also great stuff as a researcher. So we talked a bit about parachains. I tried to introduce them. I tried to tell you a bit about what they are, and then Adrian tried to give you an idea of the trade-offs. So if I was to say to you, Adrian, do you see a good lifespan for dApp developers in the future?
Yeah, of course. I mean, all of these things are dApps, right? That are decentralized applications. You're a dApp developer even if you write a parachain. That's fine. Even if you write your own blockchain, you're still a dApp developer to me. You don't have to deal with Solidity to call yourself a dApp developer. Okay,
so even if you're a dApp developer and you like smart contracts, if you switch to parachains, you're still a dApp developer. So you're just a smart contract monkey. So one of the things that Adrian mentioned was that if you want to do a multi-signature contract, like an M of N multi-signature contract, he said, well, that should really be a smart contract. And you think, okay, well, there's lots of good multi-signature smart contracts. Let's not mention an obvious one, but such contracts do exist. And but at the same time, you don't have to. You could also do an M of N multi-signature contract. It won't be a contract, it'll be a module within a parachain. So maybe Alistair, if you want to chat a little bit about that.
Okay, so why would you want to do that? So if you have a parachain that's focused on being a coin, maybe it doesn't want to have smart contracts, but maybe it wants to have multi-sig wallets. And to do that, well, you could write a module which had this code in it, and you could have governance, because we have governance relatively cheaply. That's kind of tricky to code in your own smart contract. I mean, there are ways of doing it with the smart contract, but with the parachain, if something went wrong and there was a bug and we had to upgrade it, we'd have a default way of doing that. Of course, the downside is it's expensive to be in the main logic. But multi-sigs are so important that you might want to have it.
Yep. Do you feel you could also chat about reusing modules across different parachains? Or even Andrew, if you want to chime in, maybe, if you want to talk about maybe like a substrate module and reusing it across different parachains?
So one example of a substrate module would be the balances and accounts module. So very basic, so you can create essentially a cryptocurrency, because that's the model that exists in a lot of cryptocurrencies. You just have an account, and the account has a balance. That's a simple one. But then Alistair mentioned about governance, for example. If how do you deal with upgrades of the state transition function? So I mean, that's a really hard problem, and the idea is that we'd provide a variety of options for governance. So you could do simple coin voting, but also more complex ones, like with the idea of the council. So trying to deal with the low voter turnout. Point being, though, is that it's it's pluggable. So you can choose, and there's a hard problem to solve, especially in a generalized smart contract language.
And so how might governance look if you try to do governance within a smart contract?
Well, it's possible. You have to roll your own, and like one of you was saying, it costs a lot to audit that stuff, right? Yeah.
Like right now, you copy Aragon's code. If you do governance within smart contract on Ethereum, you copy Aragon.
There's also Colony, right? I see there's a Colony member who's just stood up and about to escape. Tut, 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 tut. Just as I was bigging up your project. Don't think we've forgotten about this. So if you're watching the video, you can't see someone escaping who's from Colony. Just as we are seeing how great Colony is, they do governance within smart contracts.
Actually, I have a question on this. Not on Colony, but on upgradability of individual modules. How difficult is it to upgrade individual modules independent of the rest?
Don't know.
Okay, cool.
It should be easy, right? You have to have a vote of everyone. If you're upgrading your parachain as a governance model, you need a vote of everyone on that parachain. If it affects the state transition function, you need a vote for the entirety of Polkadot. But the change is going to be easy enough.
So this gets us onto a very good topic, because you can upgrade parachains. And when you create your own parachain, you as a developer, if you're developing it, you can decide upon what the governance should be, which means that you could make your governance very easygoing. You could make it very, very strict. You could do it on-chain or you could not. When we talked about governance earlier for Polkadot, that's mostly of the relay chain, which means of the structure of the relay chain, and then voting in or out of the actual parachains themselves. Within your own parachain, you may want to have your own governance system, and you may want to be able to upgrade that. And you may want to upgrade the modules, like a governance module or the accounts and balances module. And so one of the things which is interesting is that that's all modules rather than smart contracts which are deployed on top of the chain. But it is also possible to upgrade a smart contract. And I don't know if any of our panelists have any experience or thoughts about how might you want to upgrade a smart contract once it's already deployed.
I mean, it's fairly straightforward, right? You have proxy calls, and you upgrade the underlying libraries, and you sort of upgrade the library that you're pointing to. The only thing is you have to be quite strict on sort of the interface standards you want to keep between these smart contracts.
The difficulty there again is, I mean, who is allowed to do that? So that's the governance question again, because yeah, if you have just one person that that can upgrade the entire contract, then yeah, it's.
I mean, this is one of the things that Zeppelin spend a lot of time thinking about. So I don't think it's as trivial as, yeah, it's easy. But
well, like from a technical perspective, it's easy. Like figuring out where you want to deploy the code and how you write the code to make it upgradable. Like figuring out the social construct around who's allowed to upgrade, that's like the difficult part. I think we had a question.
It looks like we have a question. I'll run out with the mic.
Hi, thank you guys. Great chat today. So one thing that I'm conscious about is data privacy. And a couple of things that I'm thinking about, and correct me if I'm wrong here, is one, if you keep alternating the relayers around, then you're going to get different people viewing data potentially on what is a private parachain. And A, how do you stop them from seeing things they shouldn't? And B, more importantly, then when you're going to doing transactions between parachains and collators and validators that might need to see transactions from other parachains, how do you deal with the data privacy around that?
Right, yeah, so the parachain blocks that make it onto the relay chain, they're public. So to get privacy, essentially you'd have to use some clever zero-knowledge crypto stuff, right? Now, part of the design of Polkadot is that the validators don't need to know how to do the state transition itself. They only need to know how to validate it. And we could put all of that into a zero-knowledge proof and make everything on your blockchain permissioned or something. You could do. You could make everything private if you just have the collators knowing what's really going on. If that makes sense.
Anyone else from the crowd want to jump in if you want to ask a question? Do we have any dApp developers or smart contract developers in the audience?
Do we have any
Oh,
developers in the audience?
we have one person hiding. We're not going to give you a hard time. We want perspective. We want balanced opinions. Do you have any thoughts about your future as a smart contract developer? Are you interested perhaps to either build a parachain, like build your own blockchain as opposed to a smart contract, or do you feel that you are in a happy place right now and you would rather continue to develop? Let me get you a microphone. This could be good.
Yeah, right now we can't do any kind of application in public Ethereum if we want them to be remotely scalable. So having a chain per application, let's say, that's what I've got so far, would make a lot of sense. A little bit worried about how we are picking the collectors, but I mean, at least we know that the blocks are being safe because we have those fisherman pieces. So it does make sense. It's a step that seems in the right direction with the scalability problem. It's just to add something on top of that, if all of the transactions at the end of the day are validated by the same validators doing Byzantine consensus, if we have unlimited chains, that's still going to get clogged, right? How are you getting around that?
Yeah, indeed. So this is the question that someone else asked, wherever he is. So in the beginning of Polkadot, we will have one relay chain, but as that gets clogged, shall we say, there can be more relay chains. So one way that you can do that is that one of your parachains can itself be another relay chain. And then off of that relay chain, you can have more parachains and so on and so forth. And you can do that theoretically an unlimited number of times.
Now that I have 4 experts on the panel, like, could you explain intra-chain communication on Polkadot?
Possibly Alistair is the best.
So the great thing about Polkadot, because the relay chain has hashes of the parachain blocks, a relay chain block defines the state of the entire system. So what you can do, so a parachain, if it sends a message, it's going to, a block is going to generate a message. The validators who keep that block available, they're going to have the messages to send. And when the collators come to produce a new parachain block, they sort of have to ask the relay chain, the various parts of it, for messages, and then act on them. And but because they know what relay chain block they're building this next parachain block on, they're sure what messages got sent, because everything's part of the one consensus, and that makes everything a lot simpler.
So validators are keeping the state of every single other chain, and
no, they don't keep the state of any blockchain, the validators, but they do keep they would keep the messages.
Essentially, it's a proof. So whenever you have a block on a parachain, and then you want to go to the next block, you have a transition, and so you have a state transition function that takes you from one block to the next. But on the actual relay chain, you have a proof, which basically says that this transition was valid.
Well, yeah, it's not just a transition from block to block, but there also might be messages coming in and out.
Sorry, yeah, the cross-chain communication. Yeah. My apologies. So yeah, so you don't have to store all of the data because that obviously doesn't scale. Hopefully that's clearer. If you have more questions, feel free. If not, we're happy to pass the microphone on, get some good discussion, get some audience in. Oh, okay, we have someone else to run around with the microphone. Anyone else? Feel free to dive in. It isn't really meant to be just us talking. More smart contract developers. Anyone who's actually have written a smart contract? A couple of hands. Was it a fun experience? Andreas?
Sure. Yeah, it's been a while, but yeah, sure. Fun experience.
Written in Solidity?
Yeah, Solidity compiled it to a fork of Ethereum, Soil coin. It's been a while ago.
Okay. So what would you say were like the pros or the cons of your experience of writing this? So not too hippie and let's have a drum circle, but more like the hard hitting, like it was a pain in the ass, or it was really, really simple, or you know, whatever.
Solidity was comparably simple to the toolchain. To get the thing actually up and running and to be able to deploy a smart contract was surprisingly difficult back then. Solidity itself wasn't difficult.
When was this?
Must have been 2016.
Oh, right.
So, okay. So, I mean, obviously within Polkadot, we want to make that experience the same, if not better, with deploying a parachain. So,
Yeah, no. So building your own blockchain should be harder than building a smart contract. It probably is going to be harder. And building and getting it in as a parachain might be harder still. Yeah. But it's going to be worth it for some people.
Like, what smart contracts sort of allow you this ridiculous experimentation, right? Like, you wake up and like 3 hours later, you claim that you have a decentralized application that is the most secure multi-sig in the world. And like, sure, on the surface, this looks great. In practice, this results in a ton of experimentation, which is great. But on the other hand, it also results in a ton of applications that don't actually work. So like building on blockchains, building on parachains is much more akin to building your actually own web application where you sort of like have to spend some amount of time designing the entire system and then some amount of time engineering the system and then some amount of time testing whether it actually works before you're allowed to sort of like push it out to the world and like the validator set will accept this. So like that's sort of the difference between parachains and smart contracts in the deployment cycle.
Yeah, just to pick up on that point, I think a potential model for Adapt might be to start it as a sort of a smart contract, and we have the capability now to write a smart contract in Rust, and you could deploy that to a existing smart contract chain on Polkadot, and then if it became successful, then you could take the same code, the same application logic, and then just use that as the basis of your state transition function in your parachain. So that's a possibility, and even there's a possibility of you could still keep some proxy smart contracts on the smart contract chain, and then kind of migrate the rest of it to a parachain. That's a possible model.
We're going to get a question from the back pretty soon. If I can ask you a quick question. How do you see like the migration path if you are a smart contracts developer right now on Ethereum and you really like Polkadot and you want to get involved? How do you see that transition happening? Any thoughts? Anyone?
Learn Go and Rust. And then you're fine. It's like it compiles down to WASM modules. After those two languages, you just have to figure out the API interfaces that you have to implement. It's like very straightforward actually. Just like learn Go and Rust.
Yeah, I mean, if you're a developer and you can't underestimate the value of familiar languages and tooling. Tooling is a big one. It's got a lot better for Ethereum Solidity, but I mean, it's not great. So you can with Rust you can tap into this entire ecosystem of tooling, libraries and expertise, and that's huge.
Maybe actually, we never mentioned this. One of the coolest things about Parachains is that, so nowadays, people try very hard to sort of get ZK snarks into Ethereum smart contracts. And it's difficult because the EVM doesn't expose the right cryptographic primitives. In Parachains, this doesn't matter. So like you can take almost any cryptographic library from the Rust ecosystem and deploy it as a parachain. So you have access to this like marvelous, vast ecosystem of cryptography that you aren't able to access right now in the EVM.
Provided it compiles to WASM.
That's true. That's true for most.
Details. I think we had a question in the crowd, and if we could get the microphone to the chap in the back there with his hand. Thank you.
So one of the writing Solidity code was kind of full of interesting experiences for me. Some were funny and some were kind of depressing. But one of the worst, I guess, features of smart contracts was the memory limitations on the bytecode that you could actually generate and execute on chain. So do those kinds of limitations exist in state transition functions? And also the other question is, surely these transition functions need to be metered if they're being executed by the relay chain. Is that correct?
Well, I can speak to the final part. No, there's no metering imposed upon any parachain. It's up to the parachain to implement their own spam protection or transaction fee model. So that's completely open. However, it's likely that a parachain won't be admitted into the relay chain without it having a good model for that. But yeah, that space is completely open, and I think actually that's one of the most important points that you had in your slides, which we could go further into. Can you repeat the first part? I didn't.
The first part was more about just memory limitations, actually, on the contracts that you can write, because they're pretty small, really, what you can actually do with them.
Since you have no metering, you don't have any technical limitations. You may have social limitations where the validator set may not want the parachain that needs like 128 gig of RAM to run.
So if you have functions which Turing complete endless execution in theory, surely you get some kind of desynchronization of blocks and things like that.
So maybe thinking about parachains as smart contracts is sort of the wrong model. You have to think of it more like not as a smart contract, but of the EVM, or of like the Bitcoin state machine. So you have to build a state machine which is deterministic. Oh, there's another point we didn't mention actually. The parachains you're building, the state machines you're building have to be fully deterministic. And so like can't have memory leaks and like shit that just goes haywire. That's like an important point actually.
I guess also you could have like an infinite loop if you didn't have metering, I guess is what you're getting at. So with the whole point of having a gas system, for example, was, well, one thing it limits is having like an infinite loop, because eventually you're going to run out of gas. And so you're kind of asking, how might we prevent that with an unmetered parachain? Or what's our thoughts? And I think Andrew's.
Well, I mean, if you're running a sort of Turing complete smart contract chain, then you need some form of metering, because you can write any program on it. But when it comes to an application-specific parachain, it's you'll have a sort of more basic set of commands that you can do. If you've got a DEX, I guess it's just you can place an order, match an order, those kinds of commands, and you can have a sort of better mapping between. Instead of paying for how much something costs computationally, you could pay for how much value it has in the system. So yeah, you'll just have a smaller set of operations that you can do. If you have an application-specific parachain, or if you have a CryptoKitties parachain, you've just got breed and I don't know what else, but you get the idea.
Exactly. So the parachain can be specific to your use case. It doesn't have to be, Turing complete and so generic like Ethereum. You can have a parachain like this, of course, but you don't have to. And whenever you have something really generic, then you probably should have metering in order to be accepted. Alistair, or
yeah, I'm just going to make this point again, emphasize the fact that in order to get a parachain, you've got to convince the validators of Polkadot that what you're doing is a good idea. And if it's obvious that you can get an infinite loop out of your thing, they're not going to let you in.
Hopefully not. Yeah.
And in order to get any block in, we need several validators to say it's okay. And if they get stuck in infinite loops, it's not going to happen.
Yeah. So, kind of touching back upon our governance model is that there will be essentially voting in of parachains, at least in our current model. So if you come up with some parachain which looks a bit dodgy, there's a very good chance that you won't get voted on. So behave well, I guess, when you write your parachains. don't necessarily go fast and break things. Fast, but maybe not too fast. Yeah, and also then, as Alistair's saying, if you write some infinite loop within your parachain thinking you're funny, you're going to get stuck where the blocks won't be produced, and therefore you're going to have some availability issues, and quite possibly, it'd be interesting, I guess, would there be any sort of slashing if those validators get stuck in some sort of, or I guess it's not the validators, it'd be the collators, because the validators don't actually do the loops themselves, do they?
Yeah, we don't put a block in unless some validators sign off on it. So if the validators are stuck in an infinite loop, the block just doesn't go in.
Would those validators get slashed?
No, they only get slashed if they sign off on something that's bad. They don't get slashed for not signing off on something. That just relies on having enough honest validators to eventually get something in.
Hopefully that's answered your question. Cool. Anyone else? Feel free to. Here we go.
So, given this discussion, like how you're thinking in terms of how decentralized this is going to be, and it seems like it's definitely not going to be censorship resistant because some validators can choose not to, run your code. For maybe you've mentioned your code being dodgy, but tomorrow it could be any other kind of reason why not to run your code. So, and also there's this whole relayer structure, and I think you've mentioned the possibility of having a cap in terms of how many relayers and validators can there be, and also this randomness that need to play around. So my question is, given this whole scenario, how are you thinking about decentralizations and censorship resistance?
So yeah, this is important. So we're going to make sure that it's not going to be the same collator that produces each parachain block. And it may even be that parachains can do their own proof of stake over collators, which will, mean that we randomly choose the next collator, ideally. And this should give a collator that eventually gets your transaction in. Now on the relay chain end, we're going to have some number of validators, say 5 on this parachain, and we only need 3 of them or something like that to sign off on a block. So a few validators who don't like you aren't going to be able to stop this block from getting in. As long as with their majority honest, you're going to get in. This transaction should get in. Now, as to how the validators are going to scale, that's the fun part. We're hoping to scale it up a bit. One of the reasons why we're switching away from Byzantine agreement on every block is because we wanted to scale this setup. And in particular, the more parachains we're going to have, the more validators we're going to need. So when we start having hundreds of parachains, we need thousands of validators. And we'll see how the system scales, but we don't want to be too we're going to be less centralized than many systems out there, I hope.
How is it going to be for anyone to become a validator and run and all?
Well, so it's a proof of stake system. So you're going to need some stake. It doesn't have to be all your own stake. You're allowed to nominate validators. Use your stake to back someone else to be a validator. So in theory, this allows a whole lot of people to trust you. But if you can get enough stake to trust you, you can be a validator. The question of how you do that, that's interesting. Maybe.
Right. So how you become a validator. Validators are fundamentally about the problem set of running secure but available cryptographic keys somewhere. And validator, so effectively it's a full node that that you connect an HSM to that is able to sign blocks when it's your turn to sign those blocks. So in theory, everyone can become a validator. So out of the bedroom on a Raspberry Pi you don't even actually need an HSM. You can just run a Raspberry Pi and that can theoretically be a validator. The problem is that these cryptographic keys are not in custody of a lot of funds, but if they misbehave, they can potentially cost you a lot of funds. So the slashing conditions come in. So if you're actually serious about running a validator, it's not a one person hobby kind of thing. It's like you're an actual company. You have to have operations. You have to figure out how you, like, you have to figure out your security best practices. You have to figure out failover policies and all these sort of things. And given that and some amount of like public awareness of what you're doing, it actually shouldn't be too difficult to convince people to back you with their dots. Because if I don't delegate my dots to someone, I won't take part in the inflationary reward or the transaction fees.
One last quick question. Governance, is it one token, one vote?
Alistair, you're maybe best qualified to.
Well, the initial implementation, yeah, it's one token, one vote. I mean, we're certainly going to be interested in more complex ways of doing things. But the advantage of one token, one vote is it's nice and Sybil resistant. It's very difficult to game.
Is that right? Looks like we have a question behind you, if we can get the mic.
So following up on that governance issue, is it possible for, say you have a company who wants a relay chain on Polkadot, they could lobby other stakeholders to prevent competitors from being voted in as relay chains. Is that a possibility?
Voting in as Parachains?
You
It
mean
is,
Parachains?
but it would seem to be simpler to spend the money to get yourself in.
Yeah, but then you could actually lobby to stop competitors getting in potentially. Is that a case? Is that possible?
Of course, yes. Right. It's all going to be interesting what people are going to offer. Yeah. There's some very interesting questions in governance, particularly if we're going with the open voting model like we are at the minute. We'll see how it works.
That was a question in front of you, Andreas.
Yeah, possible bottlenecks. If the interchain communication becomes really much, at the moment we don't see that. The smart contracts on Ethereum, they are not constantly talking to each other. It's more like within one smart contract. But the original idea of a world computer is that all those different niches are actually communicating with each other. So what happens if the interchain communication goes up? Wouldn't that overflood the relay chain?
Yeah, there's probably going to be a limit on that. How exactly that's going to work, we've not really fully decided. I'm going to Berlin tomorrow to meet with some Parity people. We're going to try and nail this down. I'll be able to tell you next week.
Okay. Is the interchain communication metered?
Yes. But there's going to be some limit. Because
and why does the relay chain have two purposes? One is verifying the blocks of the parachains, right? And the second one is relaying messages. Why are these two purposes in one module?
Because they're linked. So it's what determines the state transition, right? So one thing that determines the state transition is, you know, what state you started in, what transactions came in, and what messages came in. So we sort of want to match messages going in to messages going out. It needs to be part of the whole system.
Could you imagine it to be a messaging chain separately?
But then how would everyone else communicate with the messaging chain? It's, so I mean, part of the issue is that we don't want to require, you know, the validity of two different blocks to depend on each other. I mean, we could do that, but we can't do that with the entire system.
You want to solve it in one block? Yeah, no, that's an answer. Yeah, thanks.
If one parachain required information from all the other parachains, would that not overload the relayers on that particular parachain more, and would that cause any issues that I can think of?
Well, yeah. So how to limit the messages between parachains? That's a good question. There will be some limit, and I suspect that what's going to happen is as a receiving parachain, it's going to be optional how many messages you act on. If you're getting spammed, you're just not going to act on all of these. Maybe they'll hang around for a bit, or yeah.
Yeah, I mean, part of it, I guess, is I don't know if you want to talk about like the ingress and egress queues. Basically, the idea of things being queued before they get either pushed out somewhere else or before they're taken in.
Absolutely. Yeah, we'll have things like that. How exactly it's going to work, it's not quite nailed down yet, but yes.
It may just look like very similar to TCP/IP, right? Like
hopefully not. Hopefully it's going to be a bit.
No, like on a high level, maybe.
It's all a bit nicer. It's much nicer.
Sure.
We have so many more assumptions that we can make in Polkadot now. We have the shared state. It's all synchronous, and it's great.
Sure. Yeah.
Anyone else with questions from the crowd? Oh, here we got one at the front.
Maybe does this work? Yeah. How would you see maybe existing dApps move over or like coexist as parachains on Polkadot? Like, for example, Maker being one of the probably most used dApps on Ethereum. Would you think it would coexist, or what would the process be?
There can be multiple processes. You could have one future in which you have sort of a bridge to Ethereum, and you only move the DAI over, but the Maker contracts still remain on Ethereum. There's a other future where we sort of port the state transition functions from the smart contracts into their own parachain, and then issue DAI out of that parachain. Most likely, I think in the beginning we'll sort of see the slow transition where we'll have a bridge first and then we'll move DAI over. But my assumption would be that someone will take the Maker state transition function and deploy it as a parachain at some point. Whether that's the Maker team or not, we'll see. But I think someone will start applying stablecoins, especially algorithmic stablecoins, to Polkadot.
Someone's already thought about this. They've said it in private conversations, so I don't want to say it yet publicly, but one of the teams who are not the Maker guys are quite excited about building a Maker parachain. Of course, it's easy to promise something and never deliver, but that would be really cool. And if it wasn't, say, back to the US dollar, but to something else, that would also be really cool. Why not experiment and peg it to the euro or franc or whatever else? So it's definitely possible.
Hello? I think even Maker doesn't have this intention to always just stick with US dollars. I think it eventually wants to be stable relative to whatever asset is out there.
Which is pretty cool.
They essentially want to issue an index fund, right, over like cryptocurrencies, which is way easier if you do this as a parachain, because you're not limited to those tokens on Ethereum, but rather you're limited to every asset that is bridged into the Polkadot ecosystem or lives within the Polkadot ecosystem. So you could realistically have a bridge to Bitcoin, a bridge to Zcash, and a bridge to Ethereum, and on the Maker chain, on the Maker parachain, you issue a stable token over those three assets, instead of being on Ethereum where you sort of like have to issue this against Gold, against a Misa Go token or something.
Anyone else want to chime in?
I'm not an expert on this, but in Substrate there's the concept. It's called there's a concept of extrinsics which might map directly to a transaction, but in Substrate there's another kind of extrinsic that you have. It's called inherent, and that's kind of other arbitrary state that the validators can come to agreement on. An example is like the timestamp, and I think you might be able to use that for oracles. So yeah, do you know anything more about that? No. Okay. That's the extent of my knowledge, so I won't go any deeper.
Good question. Anyone else? Oh, we're about 9 o'clock, which is pretty close to the end. So I guess we'll maybe try to find a pub. We can have maybe a couple of drinks afterwards where we can chat and ask. You can ask more questions or just chat to us generally about whatever. So I want to thank you all for coming. I want to thank Fabric VC if they're still here. Thanks for helping us to co-organize. thanks to the panelists, of course. Thanks for being part and sharing your great knowledge. So, thanks everyone.